Assalamualaikum and hi everyone. My name is Wan Mardiana binti Wan Ayub. My metric number is 1200943. This video is for SFT 4043 nuclear energy, and today I will be sharing with you guys about a type of nuclear power plant which is Mitsubishi US-APWR. Before we go further into our topic, let's recap what a nuclear power plant is. A nuclear power plant is a type of power plant that uses nuclear fission to generate electricity. Nuclear fission is the splitting of large atoms into atoms with smaller nuclei. For instance, when hit by a neutron, the nucleus of uranium-235 splits into two smaller nuclei along with 2 or 3 neutrons. These extra neutrons will hit other surrounding uranium-235 atoms, which will also split and generate additional neutrons in a multiplying effect, thus generating a chain reaction in a fraction of a second. Each time the reaction occurs, there is a release of energy in the form of heat and radiation. The heat can be converted into electricity in a nuclear power plant, similarly to how heat from fossil fuels such as coal, gas, and oil is used to generate electricity. Nuclear plants are being widely used across the world, and according to World Nuclear Association, as of May 2023, there are about 440 nuclear power reactors operating in 32 different countries. The most common type of nuclear power reactor in the world is the pressurized water reactor, or PWR. A PWR is a type of reactor that uses water as the moderator and coolant. Basically, a PWR has two water systems. One is called the reactor or primary system that retrieves heat generated in the reactor. The other one is called the turbine or secondary system that produces electric power with steam generated by that heat. This heat is transferred through the steam generator to the secondary system water to generate steam, and eventually to rotate the turbine to generate electric power. As the primary and secondary systems are separated, secondary system through the turbine is not contaminated with radioactive materials. As a lesson learned from the Fukushima incident, remarkable research and development is being done on new generation of reactors to promote better safety, reliability, and functions. And APWR is basically the improved version of PWR. It is enhanced in terms of its design technologies based on experience from existing types of PWR. Development of APWR has started since the 1980s as a part of the third Improvement and Standardization Program for Japanese nuclear power plants. Currently, an APWR power plant named Suruga Power Station Units 3 and 4 of the Japan Atomic Power Company is now in the process of licensing. Next, let's go to our main topic, Mitsubishi US-APWR. Mitsubishi US-APWR is the Generation 3 Plus nuclear reactor. It is designed based on the drawing of the significant expertise and experience of Mitsubishi Heavy Industries, or MHI, in nuclear power. The US-APWR is based on the APWR, a fully developed design which incorporates MHI's improved technology. It is designed specifically for the needs of customers in United States. It is highly efficient 1700 megawatt class plant which utilizes the latest development technology with better efficiency and enhanced safety systems. It also complies with international safety requirements, including those of the US. In comparison with current nuclear power plant, the US-APWR is improved from 1,180 megawatt to 1,700 megawatt electric output. The core thermal output is increased to 4,451 megawatt. For the core, US-APWR consists of 257 of 14 feed fuels, steam generator heat transfer area, reactor coolant pump flow, and also the final stage blades is also increased. The safety system in terms of both electric and mechanical system is improved from having 2 train configuration to 4 train configuration. Features of the US-APWR include the enhanced safety, enhanced reliability, attractive economy, and also it is more environment friendly.
Next, let's go to the main component design of Mitsubishi US-APWR. The first one is the core and reactor vessels. The US-APWR core improvement not only minimizes the need for replacement fuel assemblies, improving fuel economic efficiency, but also allows for long cycle operation of around 24 months, improving availability and lowering generation costs. The US-APWR has steam generator tubes that are the same size as the APWR's 3/4 inch, but their arrangement has been modified from square pitch to triangle pitch, the exceptional performance of which has been demonstrated in operations abroad. This modification increased the heat transfer area, increasing thermal efficiency. The effective fuel height of the US-APWR has been increased to 14 feet, which has increased the core's flow resistance. Since the major system loop's total flow resistance does not significantly change from that of the APWR, the large capacity pump, whose impeller and diffuser were designed to achieve improved pump efficiency, is identical to that of the APWR. The safety features include an emergency core cooling system to cool the core. This is done to combat the assumed risk of a primary coolant outflow caused by the failure of the reactor coolant pressure boundary in the PWR. Additionally, it is built to ensure redundancy by securing an electricity supply from the emergency generator, allowing it to continue operating in the case of a station outage. By using this 4-train layout, connecting piping between trains is removed, improving system independence. For layout design. According to severe seismic circumstances, the building width for PWR plants in Japan must be determined based on the building's ground contact ratio during an earthquake. Because U.S. seismic conditions are less severe than those in Japan, it is conceivable to employ smaller building widths and to minimize the volume of the primary plant building by using a layout with scattered small-scale structures rather than a single large-scale structure. In order to prevent interference between trains caused by a malfunction in one train, the sections where such features are installed must be distinct and independent. Each of the 4 trains for the US-APWR is situated in one of the building's 4 corners, realizing a sensible configuration that minimizes building size while also ensuring isolation and independence. Finally, the instrument and control system of Mitsubishi US-APWR. From the perspectives of operability and financial effectiveness, an advanced main control board employing total digital technology has been implemented with reference to the instrumentation and control system. To reduce cable volume, this lessens the loads on the operators.
In conclusion, the US-APWR is a superb plant that assures safety and dependability utilizing tried and true technology, increases economic efficiency by boosting production, and delivers great plant performance.